All right, today we're going to start talking about passwords, and we'll have some fun today. If you've got Kali open, that would be good because you can then go through and do the actual commands that we're doing up here. And the assignment for this week is to crack 100 passwords. And I'm giving you the list of it, so all you gotta do is just copy the commands in, and you should be able to do it, no problem. All right, so how strong do you think your passwords are? Yeah, okay. All right, now mind you, on Kali, the when we go to start cracking them with Hashcat, the word list that we're using only has like 13 million password combinations in it. You can download a bigger one. It's called RockU 2021, and it's got 13 billion passwords in it. So if you think your password is really strong, it's probably not. So we're going to go through and we're going to look at a lot of this stuff. Okay, so right off the bat, though, one of the first things we're going to do is we're going to check some password strength here. Let's see. See if I can find the URL. All right. Let's see. We probably don't have any internet here on this machine. There we go. All right. Go to bitwarden.com if you have connectivity /password-strength. Let's see if we can actually get there from here. Yeah, there we go. Now this is going to show your password when you type it. Okay, so we don't want, I'm not going to like type my password up here, but you want to type yours where nobody can see it. But I mean, like, let's see, how about QWERTY? That's a common one that everybody, yeah, bad password. Okay, and it tells you it's red. Now, what if we add 1, 2, 3, 4, 5, 6 after it? That still is terrible. Okay, what if we add a pound sign after that? Still horrible. What about exclamation and an @ sign? Still terrible. Okay, and if you look down at the bottom here, under it, it says estimated time to crack 12 minutes to crack that. Okay, so not good, right? Now let's try, here's one that normally people use. Capital P A S S W 0 RD1. Less than a second. Okay, so you guys can sit there and use this to see, you'll kind of get a guesstimate of how good your password is. Now, here, I'll type one in that's similar to what I use. Okay, there's one. It says it'll take about 2 years to crack. Yeah, so that's what you're wanting to get. You want it in the green. Okay, so I suggest you guys make up like a mnemonic for your password. Okay, like this one right here would be bang you up and take your money at 11:30. Right, just something easy for you to remember. Okay, because you never want to write it down. Okay, I mean, it makes sense, right? Yep. So you make something up, just kind of, you got all the special characters up here. You can rename those to something like the caret is up, at, bang, pound, so you got things you can use to make up a password. But what do you think should be in a password? The things that you could shift and then a number. Right. Special characters, definitely. There you go. Yeah. Yeah.
Centuries.
Three.
Look,
Centuries.
I just random.
Yeah. Well, if you go like if I type mine in, like what I just typed in, that one was too short. So the length and the randomization is the key thing. You do not want any dictionary word in any language on in your password. Okay, so you can't, if your dog's name is Bob, you can't have Bob in your password, right? Because that's going to make it real easy to crack. So what's a good password? Okay, a mix of upper and lowercase letters, numbers, and special characters. And you want it to be at least 16 characters long to be a good one. Okay, so
What if this is actually a website that's taking out all of our passwords because we're giving it to them?
good question.
That's
But without, it's just a random word. You're not associating it with you. Now, if you had to log into this, yeah, that would be a bad thing. Or if you put your email in it, because what do 90% of all websites use as your username? Your email address, right? So that's 50% of the algorithm to get in. Okay, so you never want to give somebody, your username and password. Obviously.
That'd be pretty interesting to create like a scam of this, like make people actually give them your passwords. I mean,
Oh.
they're literally eating it.
Well, let's put that in a different perspective. What do you think a phishing email is? Because a phishing email. We haven't really talked about that, but we're gonna. Okay. Yes, you get email all the time. It comes into your box, and it might say, attention, your account at Amazon has been compromised, and we need you to log into the portal and reset your password. And what they do is they don't send you to Amazon. They're sending you to someplace, probably a foreign country someplace, or a compromised server in the US or something. You go there and it looks just like an Amazon login page, right? But when you type in your username and your password that you think that is supposed to be right, what happens when that happens? All they do is just capture it. And then they send you to an error page somewhere and you get frustrated and eventually just give up. Okay. Yeah. Oh, definitely. Yeah. Easy Pass. I hate them. Every time we go to New York, it costs like $100. So, yeah, it's not very easy. So anyway, you have to be careful with the phishing emails, and we're gonna have a whole class on just phishing emails and how people try to compromise you. But right now, we're gonna hit the basics with the passwords. Okay, so why do we need to have a good hard password? One that we can't remember, right? Unless you use the mnemonics thing I just showed you. Or you don't want to write it down. Don't ever write it down. You can use a password manager. Those with Apples, you have the built-in password keeper, which is really handy. Okay, especially if you got the touch screen, so you just hit your finger on there when you go to a site and it logs you in, which is cool. Yep.
Can someone hack to your finger scanner thing?
Yes, there are issues with biometrics. Okay, and that's scanning with something you are. Okay, your retina scan, your palm print, your fingerprint, anything like that. They can be compromised, but typically it's not going to be you that gets compromised as much. Let's put it in movie perspective. Okay, they need to get into the data center that you work at, so they come cut your hand off so they can use your finger. Okay, that's how they would compromise you in that aspect. But the company and the back end that's running that, they may compromise them and get that biometric data, but they're not going to be able to turn that into a handprint to use it, or a fingerprint. So it's fairly safe, but it's personally identifiable information about you. So, your retina scan, your palm scan, your finger scan, all that information, is you. So it is personal. You don't want it to escape, And let's see. So a lot of these companies, remember we looked at the site last week, Have I Been Pwned, right? Where you go in, you put your email, which is your username in most cases, and it tells you if it's been in any breaches. Yeah.
We were doing another experiment with that, and we found out that in one single syllable at gmail.com, apparently there are a whole lot of those that have been compromised, like 364 or something like that.
Yeah. Oh yeah. Yeah, there's many. Like I say, if you we're going to look at some stuff today when we start cracking passwords, and I think you guys will find it rather interesting how fast password crackers work. Now, your systems may be a little bit slower when we get to the cracking of passwords. So, you like for the assignment, we're going to crack 100 passwords, and it's the most common passwords on the internet. So, your laptops, may take a little while to chug through them. So you may have to do it like on a Saturday or something and just let it run. But if you have a faster laptop, these should crack in less than a second, all 100, or maybe 99 of them. I think one of them is actually a good password. So, all right. So, how would you make your password, and how would you keep your password, secure? I mean, we kind of just talked about it with a password safe, but I mean, you guys got to remember your password is kind of like underwear. Don't share it and change it often. Okay? All right? Just throw that out there. So maybe it'd be funny and you guys would remember it. Okay? So, oh, somebody's coming up with good passwords. Huh?
Because like I typed in my email as my password said they take centuries to crack.
Oh, for your email address. Yeah, because it's typically longer, right? And change, like for your email address, change like 1 or 2 characters to uppercase, and see how that affects it.
Like I literally typed in my email, and
Yeah.
it says it takes centuries to crack.
Yeah, I mean, the longer and more complex without dictionary words is going to make it harder to crack. So, all right, now that we've seen that, let's go look at. We're going to use a tool to crack emails called Hashcat. Okay, so it's a very fast password cracker, and what it does is you don't actually get like, the password is not going to be like encrypted or something. It's going to be hashed. You guys know what a hash is? Nope. That's correct though. It is the hashtag. It is a symbol, but not what we're talking about here. All right, it's a mathematical function. It's one way. So like if I take, I need to make this bigger again, dang it. Let me make this a little bit larger. Because y'all probably can't see that, can you? Okay, let's see if we can.
My banking account password said centuries, so I think we're good.
There you go. Well,
but it's written on notes.
If it's written on a note somewhere, it probably takes seconds. Yeah.
Yeah, hear that.
A computer note's worse than a physical note, because if someone compromises your computer, then they've got access to your file, right? So unless you encrypt it or do something else. But we're going to kind of go through this and talk about how passwords are stored on systems. As soon as I can get this to where you guys can read it. All right, can y'all read that? All right, we'll leave it right there. All right, so a hash, we can look on here. Let's look at the shadow password file. All right. Okay. See the one for parallels down at the bottom, right above the second one up? All right, you see that big long string there that says $Y, $J9TSE, blah, 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 all the way across, and it's got a slash in there and some colons and periods, right? Okay, that is a hashed password. All right. So it is hashed with assault, i.e. like you basically just, it's a random number that you throw in, and then you hash it against that plus the actual password, and it just gives you an extra layer of mathematical complexity. All right. So this is how systems store it. So like if you break into some web store and you find the password file for all their users, right? It's going to have like a username and a hash, and that's what's going to be stored for it. Okay. And that's what comes out in these dumps. So that's what you actually crack. So we're not going to be it's not like we got a username and a password and it's, like encrypted. We're going to break the encryption. We have to reverse a one-way hash, which makes it really hard, you would think, right? If something only goes one way, how do you reverse it and get the answer out? Okay. So let's start with a simple hash. All right. We want to, let's say our password is Bob. Okay. Nice and short, right? If we're going to hash that with, there's multiple algorithms, MD5, SHA-1, SHA-256, SHA-512. Okay, those are just some of the hashing algorithms. So, but if we type in, we're going to use MD5s for everything today just to make life easier because they're shorter. Okay, if we do MD5 sum, and you'll want to know this command. Okay, and then let's type in Bob. And this is probably not going to work at all. No such file because it's looking for a file. Okay, so in order to hash that word, we're going to have to do something different. All right, so we're going to type in echo -n for no carriage returns, and then we're going to type in Bob. Then we're going to pipe that, okay, to MD5 sum. And what this is going to do is it's going to do the mathematical function on the word Bob, and it's going to come out with that. That's the hash of Bob. Notice the length, okay? Now let's change this, and let's go to Bob, and then a whole bunch of random characters, okay? Let's hash that. Wow, look at that. It's the exact same length. Okay, this is a fingerprint. Okay, nothing else, theoretically, nothing else will have the same hash as either one of those. So Bob, or here, and if we change Bob, okay, let's say we change Bob to capital B. Yeah. All right, do you think the hash will be the same? No, it's going to be completely different. How about that? It's completely different for a capital Bob versus lowercase Bob. Okay, so this is how we can tell the integrity of that password, and we have that hash. Now, the other thing we use hashes for is file integrity. All right, so how do you know if the file you downloaded from some internet site, how do you know it's legit? Okay, that it hasn't been changed en route, or a hacker hasn't got up there and put malware in it for you. They will normally post a MD5 hash or a SHA-1 or a SHA-256 hash of that file. So let's see, what do we got in here? All right, so we got 3 files in there: eda.txt, hashes.txt, and test.txt. All right, how big are they? All right, let's do test. All right, if we look at test, all right, it's got those hashes in it. All right, if we hash that file now, MD5 sum test.txt, okay, it's telling us right there that's the signature for that file, and then the file name is off to the right. Now, if we do something like this, vim, and we edit the file, and let's just add a line and put a 1 in it. Okay, that's all we're going to do. All right, so say the hacker just goes in, he compromises that file, and he now puts his malware in it. If we hash that again, and if you look at it, It's a completely different number, right? The hash is completely different. So that's how you can tell if a file is real or not, okay? You go to download a tool from Microsoft, they will give you a hash to it, okay? Or like you go to Wireshark. That's a good one. Let's see if we can do that, because that'll be a good example. All right. Let's go to their download page and let's see. Somewhere in here, I think they have the hashes. Yeah, let's just type that in and see if they got a page. No, we don't want an AI answer. We actually just want the page. And of course, Bing or Google is not cooperating.
The source code?
There we go. All right. Okay, no MD5s for Wireshark. Okay, let's get to the latest one. All right, so here's the latest version of Wireshark. I don't know if it's going to actually show us what we want to see.
You download a file to make sure that next downloaded file is safe.
Yeah, exactly. They used to just list it on the site. They'd have the download, the version, and everything, and then right under it, they'd have the MD5 or the SHA-1 or the SHA-256. All right, let's see if we can open this file. Oh my gosh, that's a big file. This is the source code. It's listing, it's got everything in here. All right, so anyway, when you guys go through this, you should be able to see the hashes on the sites. So you'll know which, you can check it when you're done downloading it. So, I mean, you can see how good this is, right? How easy and simple it is. Now, how do you think you would get a SHA-256 hash? On Linux, it's a little bit easier than Windows. But all you would do is just, instead of MD5, sum, obviously this is the MD5 is the algorithm you're using, the function. Sum means you want to get it, right? It's a math thing, right? So it'd be the same thing. SHA, we can do SHA-1, sum, and then the file. And you see it's a little bit longer, right? And then if we change that to SHA-256, boom, it's a little bit longer, okay? And what do you think is going to happen if we type in 512? A little bit longer, right?
Is that 512 characters?
No, it's if you look at the actual encryption algorithm, that's talking about the complexity of it. So like the bit depth. So they're using a much bigger seed for doing the algorithm. So instead of saying encrypt it with 1, you're saying encrypt it with, say, 27,325,000, or some kind of crazy number or something, right? It's a much larger number, so it comes up with a longer signature file, obviously, but
So why 512?
more complex. The higher the number, the harder it is to break into the key. And you'll see that when we start actually cracking these. So let's see here. See what else I had on here to cover. All right. We've talked about passwords and good passwords. All right. Okay, so in PowerShell, which is completely different from any Unix-based system, you're going to type a much larger command in. All right, so I will read it from my phone. All right, so you want to do MD5, right? You're going to have to do get-file hash space the file name test.txt dash algorithm MD5. Much easier than Linux, right? Not. Microsoft makes everything extremely complicated and over the top. And of course, you do for all you're going to do on this is for each one. If you want to do a SHA-1, you're just going to change the algorithm to SHA-1, or SHA-256, or SHA-512. But still, it's just ridiculously complicated with Microsoft. You got to type in how much more stuff than just MD5 sum and a file name. So, but PowerShell is very powerful. Get it? And we'll see that. We'll play with that a little bit when we get more toward the scripting side of the house here. All right, so how do we crack a password like this, right? I mean, you gotta use a tool, right? And there's this great tool called Hashcat. All right, let's do this. If we can do -H. Okay, Hashcat will gives us a bunch of algorithms to use, right? I mean, it's not just the few that we've talked about today. There's literally hundreds, maybe even thousands of algorithms that people are using. Like for a Cisco router, that algorithm looks completely different than something a password list on a Unix box would have. So let's just see if we can look at the algorithms here. Scroll back up. You may have to go to the website to actually get it. I don't think it gives it to us here. Nope. All right, but -M, okay, is the hash type. Okay, so when we do Hashcat, we're going to do -M and then a number. Okay, and that number is going to correspond to the algorithm we want to try and break. So let's go over here and see if we can get a list of the algorithms. Let's see if this is it. Yeah. All right. So, let's see. Can y'all read that okay? I mean, it's kind of small, but it's a big list. You can see hash mode 0 is MD5s, and then it gives you an example of the hash, okay, an MD5 hash. And then you can see MD5 with pass and assault, and it gives you that example, and that's of mode 10. And you go on through, and there's a few. So there's a lot. Okay, and you see the example hashes over here. Like, remember that one we looked at for the shadow password in the Linux file? You can see there's some large ones that are even larger than that. So we're almost to the bottom. Almost. There we go. Okay. Now, those are just ones for what you might encounter if you're pen testing something like, let's say you find a, let's see, scroll back up, like there's a SAP password that's type 35,000, or you may run into, have you ever heard of Mega Download? Not in New Zealand. It was a place where you could get all kinds of stolen, software. A lot of people use that. We got compromised too, but that big database, if you find the hash that they're using, that hash type would be 33,400. And that's what you put in for the mode. And of course, it has a very large, if we look at it right here, looks like it's about like a 256 hash, but it says that it's PBK DF2-HMAC-SHA-512. So that's just a completely wild variation of a SHA-512, right? So this is where you would use this list, okay, when you're trying to figure out what kind of hash you got. And then if we get down here, there's another list for specific hashes. Like Joomla is a content management system, like WordPress or Squarespace or any of these other ones. And if you compromise that, this is what the password should look like if it's below version 2.5.18. So you would use that particular mode, which is 11. Then there's Postgres, Juniper routers, Skype. Here's a format for a Skype. So if you break into somebody's computer and you grab the hash of their Skype username and password, it'd be code 23 to actually break it so you could read it.
So is this website just to have it, like, if you hack something, this is what it's supposed to look like? Why does this website even exist?
Well, because what happens is, let's say I'm pen testing something, right? And I break into a system, I get access to it. And I start rummaging around because that's what we do. The data is to see what you can get. And when you start rummaging through it, you find all kinds of weird things. Like I may, if it's say it's a Cisco router I'm in, and I get to the section where it's listing the enable password in the config file, it's going to be hashed. So I can just go through this and say, okay, if somebody, a lot of times I won't be in the router, but I'll be in a system that the guy that configures the router uses, right? So in he's probably got a copy of his config for each one of his routers. Okay, so I find that on his laptop. I'm rolling through and I'm like, is this a Cisco config or a Juniper config? And I roll down and I find the enable password, which is the root password on Cisco or Juniper. And I see this hash. Then I can come check it over here to see exactly which mode it is. Because if I got to brute force it, it could take 30 years. Don't got that time. So that's why this exists. And this is the good guys. This is the guy that make Hashcat. Now, I mean, you can kind of call them good guys. I mean, because the bad guys use this software too. I mean, it's really, really good and works well. Ooh, look, here's a Mac OS hash. So if you dig through your Mac, if you have a Mac, and you find what you think's your password, and the hash looks something similar to that, then you say, okay, well, let me try that. You try mode 122. So as you can see, there's a lot of stuff here. Bless you. So lots and lots and lots of hashes. All right. So let's jump back over here. And here's how you actually crack something. Okay. So there's a word list. All right. So like in this one, the one that comes stock, when you download Kali and install it, is the RockU text file, and it has, oh goodness, 13 million passwords in it. Okay. And what this does, and if we're going to look at it here, so cd/user/share word list. There we go. All right. So when you get there, if you list the directory, you're going to have one that says rocku.gz. Okay, it's a gzip file, so you're going to have to uncompress it. So that would just be g unzip, all one word, space, the file name, rocku.gz. And it's going to run for a minute, and as you can see here, it's a fairly large file. Just this guy down here, right? And it's big. It's 13.9, is that gig? Yep, gig, 13.9 gig text file. That's a big file, right? If you tried to open that in anything on Windows, Excel, Word, it would just die. There's not enough memory in the world to make Windows open something that big. So let's look at it. On Linux, being that it's the superior operating system, you can look at that, no problem. We're just going to type in more and type in the file name. Okay, there's the first 20-ish lines, and those are passwords. These are this is the, let's say, 13 million bytes of text, which is a lot. So we can actually, just to see how big it is, how many lines do y'all think is in there? Huh? Guesses? All right, let's see. Huh? Well, let's see. Let's cat the file. Okay. Now, if you cat it, it's just going to run forever, right? But if we pipe it to the other Unix command, WC, word count -L, which means instead of words, give me lines. Okay, it'll tell us how many lines are in it. Got to type the command. There we go. 14,344,392. And this is the small list. Okay. Like I said, the other one has 13 billion passwords in it. So these look like they're clear text, right? So how are you going to compare that against a hash? What do you think Hashcat does? It's multi-threaded, and it just literally takes every one of these, hashes it, and then compares it to the hash you gave it. Does it match? Nope. Next. Match? Nope. Next. And just keeps doing that, right? Until it finds a match. So let's look at one of these files that I have in here. CD. If you ever want to get back to the directory you were in, CD space minus. That'll take you back to where you were before you came to this directory. Okay, so pwd. See, now we're back at home. And if we go CD minus into a pwd, we're in user share word list. So just CD minus, and we go back to the home directory. All right, so we got some files in here. ls-al star.txt. G unzip, and that's all one word, just literally like it sounds, G-U-N-Z-I-P, and then file name. Yeah, and it'll take it a minute to unzip it, and it's gonna, it's kind of big. It's like, so it might, depending on how much space you got left, if you try like that big one, it's 13 billion passwords. Yeah, it's gonna be, you need like a terabyte on your drive to just even think about unzipping it. All right, so we got 3 files here. One of them is 3,300 bytes. Okay, not that big. Okay, but the other 2 are much smaller. So let's look at the one with 266. All right, it's got what, 8 hashes in it, something like that. It is. I'm going to take that 1 off at the bottom there. Oh, no, we don't want to do that. I want test. Oh, there we go. All right. You just hit DD, it takes out the line you're on. Then escape colon right quit. Right? Y'all remember all that from BIM because we're going to need it later. And if we look at it, we now have that 1 is gone. All right, so we're going to crack that file. Okay, these are not hard passwords. I don't think there's any one of them in there that's difficult at all. So Hashcat. Okay, let's spell it right. -M. Okay, and we know these are MD5s. So 0. Can you guys see this? Because this is going to be what y'all need to do your homework. And depending on how fast your laptop is, it could take anywhere from 1 second to maybe a year. All right, so -A, 0, that's the type of attack. Okay. Then the file we're going to actually try to crack. And we're going to call this, was it test? .txt. Okay. Then we're going to tell it where the word list is. And then we're going to type in -- status just to see the status of it. Okay, but before I do that, let me just do it. And then, okay, it just ran. It found some of them, found 6 of the 8. But I want to go delete something first. There's a file that you're going to go to actually see what the results. So it's called a pot file. Okay, you see right there, you got that one. It's called hashcat.pot file. That's your answers. Okay, that's what it found. POT stands for, like, I think, potential passwords. You know, they don't want to say it's 100%, but that's what they think it is. So I don't know. That's my guess on it. But I'm going to remove that. It'll create a new one when we run the list again. All right, so let's take out the status and run it. Okay, and you can see it's going through it, chugged through it. And if you scroll up, you can see right here where it says recovered. Look about halfway up the list here. It recovered 6 of 8. Where is, told you how many, it was able to hash it. This is kind of the speed of this computer. It was hashing it at 4,751.2 kilahashes per second. So kilo means 1,000. So 4.7 million hashes per second is what it was hashing at. So it went through pretty quickly. And let's see, you can see right here it started at 9:17:37 and ended at 9:17:42. So just a few seconds, right? All right. And then if you scroll up here, it will tell you as it finds stuff, it's going to tell you. So it found QWERTY, hello with a lowercase h or lowercase h, hello with an uppercase h, cyber, password, and leet hacksaw. Okay, it found those passwords out of that hash list. So there's 2 of them in there that it didn't find. And the other list would have found them just like that because it's larger, but it was like 2 vehicles. I think one was like Porsche 1, and I forget what the other one was, but you know, those were things that this list, because it's only got 13 million, it's not going to get it. But the other list with 13 billion, it would have definitely kicked them out, just bam, just like that. Now, it does take a while to run the bigger word list. Like we cracked one at work 2 months ago, and we've got it running on forensic evidence discovery box. It's a big machine. It's like a $14,000 machine that we bought, and it's got a big GPU in it. And we ran it through there, and we had, like, I don't know, 30 passwords, and they were all complex. And the estimated completion time was like 3 months. So we just let it run and run and run, and it eventually got them. So, all right, so let's look at the other file that was in here. All right, not that one. Hashes.txt maybe. Or is that one just the, yep, that's it. This is the one you're going to crack for your homework assignment. Okay, it's got like 100 in there, I think it is. Just count it. It's got 100 lines in it. Okay. So 100 is the top 100 worst passwords that have been found on the internet. Okay. So you don't want your password to be in this list. All right. So let's see. And that was hashes.txt. Let's do this. All right. Any guesses on how long it's going to take?
Last time was 5 seconds, so like 30 seconds because
Let's see. It took 3 seconds. And it cracked 99 of them. So that's a good question. I would actually have to compare the two lists, compare the pot file and the that one file that I had just a list of words in it. That was the actual passwords, and I hashed all those to create the MD5s. But yeah, so there's one in there. We can do a diff on it though. You can actually compare the two files. Let's see. Diff. Local.share hashcat. Let's see. It's not. That's how you. That's the command you would type. I don't have the path right apparently. Let me take that slash out. Maybe that'll work. There we go. See where it's got the green arrow that points this way to the right. If we scroll up through this, we should see one that's red. There we go. Here's some that are in one file but not the other file. Yeah, so there's that one list has some that aren't showing up in the pot file for some reason. But the pot file said that it found 99 of them.
Did you make all these names? Did you make all these names?
No, these are literally on a list on the internet of the top 100 worst passwords. Huh?
So my dad's name is on the worst top.
So, well, I guess that's it. We got we're at the last minute here. So, y'all gonna make better passwords now?
Mine was good too. Mine said centuries.
Okay. But do you have it written down though? Or typed on a note on your phone, which is worst.
Will this video be like before the homework? Because I'm gonna have to rewatch it. The video.
Yeah, I'll probably put it up tonight.
Perfect.
Yep.
Years.
So, all right.
All right. Thank you.
Yep.
Yeah.
Shut down.
My Kali isn't working. What was if I wanted to make a new one? Start over?
Yeah, just all you're gonna do is just go to in VirtualBox, just put in new.
Yeah.
And then you're going to point the VM. VM name is just going to be what you want to call it. And then the ISO, you got to select the ISO file for Kali.
Which one is it?
It'll say Kali right there. Use this is it Intel or Apple Silicon? You know, is it M1, M2?
I don't know.
Okay, go up here and hit the Apple real quick, and then go to About This Mac. Okay, it's an M1, so you want to use ARM 64. Yep.
Okay.
All righty.
Thank you.
Yep.